So we're going to cover Unit 10, Chapter 12 today. And in this unit, we're going to talk about indicators and also monitoring the networks and systems to be able to detect threat indicators, and giving you a little bit more perspective as an analyst. So we would start with the bigger picture, which is going to be your networks. And in network systems, as we talked about how we look at logs, we want to start with the routers. Why the routers? It's because your router is your first device that is receiving inbound traffic, and it's the last device in your infrastructure that's going to send out traffic from internal network. So border gateway are typically routers, and routers are important to be monitored because any kind of attacks that's coming in externally, that it's going to hit the router first. The router is kind of like the freeway that's going to take you to the exit to your network, right? So we want to be able to look at your network flow information and your network border devices, like your router, is important. So in the first question, it asks you about 3 basic methods of monitoring. And so we want to start with the router. We talked about how the router would be able to receive, right, and be able to pass the packets that are coming into your network, and also passing the packets that are leaving your network. So that's going to be for internal boundaries. We're going to look at some routers that can be used for segmentation inside our network. So you might have routers that are connecting different type of segments that you isolate for the department, for branch, for region. So internal boundaries, sometimes that also needs to be monitored. So you want to be able to see the activity. Now, in the technique, we would have 2 forms of monitoring. One is that we are going to collect the data from the appliance, like the router, that contains routes, which is going to be the path that passes the packet from source to destination. So if I'm sending data from my system, right, to a web server, like I'm submitting some information into a form, the router would see that information as packets, but it creates a path for my system to pass that information back and forth, right? To send and also to receive back, because most of the things we use in that kind of environment would be, it would require some form of handshake. So routes can be dynamic routes. A lot of the times it is. Why dynamic? It's because your routers have different type of service or protocols. And what that does is sometimes that it determines which other routers are available to pass that information on, or it might have a specific dedicated path, which is going to be your static route. So we can look at if there are different type of routes, and if there is some kind of latency. If you have delay, possibly maybe because communication, devices, or it could be cabling. It could also be data content inside. So your payload might be something that can also cause the delay. And in the case that if you have locks, right? So you want to be able to check the pathway that your data goes from one point to the next. Now that's going to help you determine also attacks like denial of service attack. So when you have denial of service attack, you're going to get a lot of requests to your server target. That means that we're going to be able to see the data coming in, right, from the attacker and aiming at our system. So the router asks the device to be able to pass that on. It's going to take that information and bringing that into the network. Now, the job for your security appliance, like the firewall or your IPS, is to be able to filter or block that, right? So in just the router, we want to see the performance of our network and the communication elements of our network. So that would include bandwidth, how well is our systems communicate, and then the content that comes in and out of your infrastructure. That would be the specific packets that's being sent in. So when you're doing that live with your router, let's say that I'm recording the logs, I'm analyzing the logs that is currently storing the information of active connection, active communication, that is considered active monitoring. Now, if you're doing passive monitoring, just like how you did malware analysis in the last lab, you take a snapshot of your network activity at the moment in time. Let's say that I do that at 8 a.m. this morning, and I record my network activity for the heightened the most busy time, right? Like let's say from 8 to 10 a.m., that's when there's a lot of activities that's happening in my network to kind of capture the performance, the traffic that's being passed into my infrastructure or leaving my infrastructure. So that way I can determine maybe the average of performance in my system or determine the benchmark, right? The type of services and protocols that's being used, the payload, and so on. Who's sending, who's receiving. So when you do that, it's actually passive monitoring. When you basically take a capture for a certain amount of time, and then you go back and evaluate that particular analysis or that capture to look at your content and perform analysis about your network, right? So not all networks and admin prefer to do active monitoring only because it requires system resources, right? And it also requires a lot of effort from the technical team. So what you see is that even if you automate some of this, right, you're still going to utilize system resources. As you are monitoring, you are going to run software and hardware to be able to monitor live, right? And if you have a lot of data, you're going to have to store that somewhere, because if you're running the active monitoring all the time, 24/7, that's a huge amount of data that we're looking at. So some company, they would prefer to go the passive monitoring route. So we want to start with your network monitoring techniques. And sorry, to switch back over here, there are a few tools that you can use. If you want to look at traffic flow in and out of your network, these are the common options. You can use SFlow, JFlow, or NetFlow. You can also use Armon to monitor the lower layer, right? Layer 1 through 4. That means including route. Route is part of the network, right? Anytime that you deal with IP address, that will be at the network layer of the OSI stack. Now, if you're monitoring devices that are being used, a lot of the times you have to probe the device. You have to query it, right? So in some tools, it requires the system that's monitoring the others to query the others. So if I'm using, let's say, one server to monitor all my systems on my network, my server that's being used for monitor have to probe the other system, right? Status, like what, information, so that way it can pull the data. So in some cases, like I said, it will require resource. And then you would use simple network management protocol. SNMP is a huge part in infrastructure management. It is a way that we can do inventory for our system. It collects all your system information, the specifications, the status of your system. So if you have 10,000 systems on your enterprise network, we don't go one by one and handwrite. That can create error. So we would use a service right? A server that runs SNMP. Now, it doesn't have to be an actual computer. It can be an appliance, right? Like a network appliance that runs SNMP. So you still can add additional tool, right? Like what we said up here, we can have NetFlow and Armon included with SNMP. So the whole point is that you're going to use the tool for that specific service. And it will look something like this. So behind, right after your router, you're going to connect a system, an appliance or a system like a computer system, a server, to be able to gather the data of your border router and also internal routers that are used for segmentation of your network. So that brings us to number 2, right? What type of monitoring mechanism are included in PRTG, your Password Router Traffic Grapher? Typically in this particular set of tools, what you have is you're going to have Network Sniffer. Wireshark is a network sniffer. So a lot of times you're going to see application or software that's being used to analyze the protocols that are used in systems across the network. And then you would have JFlows, NetFlows, or those tools to be able to look specifically on the traffic. It's kind of like having a camera system on the 91 freeway and looking at, where's the congestion, right? How is the traffic flow? Sometimes you see that on the news and the media where they show all the cars are coming through and there's absolutely no traffic. So the flow tools are gonna help you determine, right, your performance, the type of activities that are happening across your network traffic. And then we touch on SNMP. This is used to manage your systems that are interconnected. And then WMI is a Windows tool. This is a component that is used with your Windows infrastructure. Why do we select the Windows in our lecture? It's because the majority of the business have some form of Microsoft servers, whether they're using it for authentication, like such as or DNS and Active Directory. Sometimes you will see that using with web or everything, right? And even in cloud environment, cloud has specific tools that are really dedicated for the product, but a lot of the times, depending on the service that you have. So that was a question on Monday from one of the students was like, can I use the same tool if my company is electing clouds or using cloud? You can use the same tool if your service provider permitted. A lot of the times they will manage some of it and then they would allow, right? They would allow you to integrate your tools with their product, or they also provide cloud-based tool. Basically, it's a way to interface the management of your network traffic in a remote servers at their data center. And most of your cloud product now have that set of tools, but you would also be able to integrate SNMP as a service, and then with that, you can use, console base or some kind of software that works with SNMP. Any question regarding network monitoring, right? So one thing I also want to bring up is that when you interview for questions, right, you might go for an internship as a cybersecurity analyst in charge. They would ask you, like, how do you know if the network is facing an attack, right? You need to be able to provide an answer. A lot of times we want to be able to give it a higher level and then break it down, right? Go through the process. So you can say, if we're actively monitoring, we will be able to determine, right, if the attack is going through, and we can look at appliance logs. We can also use command-based tool. Ping it works across all operating systems, right? If you're running Linux, if you're running Windows command prompt, ping allows you to check the status of your system using ICMP, which is your Internet Control Message Protocol. This works at layer 3, right? So we can look at to see if that system is responding, but it's still probing. Ping is a command that probe the system, it query the system, so you can do echo and request. Now, you can also use iPerf. This is a tool to look at your bandwidth, the maximum bandwidth that is used. So this is used to test your network performance and to be able to give you an understanding of, how good is your network? What is the performance level? And that's really helpful in the case that if you have a spike, that's a good indicator, right? If you have denial of service attack, you're going to have a huge pickup on your network bandwidth. It's going to be a huge demand. Now, the way that we can dilute that, right, with quality of service in the network is we can take that traffic, that attack traffic, and we can redirect it into a certain direction, maybe like a black hole system to absorb it, or we can block it, right, using some kind of security appliance rules like firewall. So what you see is that definitely these are important things. So in your interview questions, you can talk about passive monitoring. You can talk about active monitoring and indicate like a little bit of what you would do, like what kind of tools you would use to be able to determine that, to gather that information and analyze it. So as an analyst, you need data to be able to give you a constructive decision, right? So what we want is we want to be able to take the information that's given to us by the software and the hardware appliance, and then we want to be able to interpret that, right? So the AI component now in a lot of the security in the IT service company is that they're training the AI model to be able to make a appropriate decision, but they still have engineers that are really looking at whether it's effective or not. You know that LLM is only going to be effective to about 70-80% because there's still inflation and a lot of it is hallucination. So the decision making process has to be better, right? So over time it will be improved. But when you're doing this manually, you're going to have to take the data and interpret it. And to be able to say that, oh, this is an attack. And this is what we're going to do with this to respond to this attack. This is what we talked about last week. Okay. Now, the 3 common industry tools for network traffic analysis is Nagios, Cacti, and SolarWinds. You do have other tools that are proprietary, and it comes with sometimes the security service or package that you purchase in the organization. When I teach 30B, which is a Python for networking, you can incorporate some of these tools with your Python script. Let's say that I can write a Python script to activate SNMP, and then I want to be able to run like JFlow or NetFlow with my script automated so that way it can check my traffic flow. And then in addition to that, you can specify like what you want for the result. What is it going to be looking for? So some of these tools can be very useful in the automation process. So that way you don't have to check every single system in case you have many, right? And it reduces the error that we see in an aspect of network monitoring. And many of you, right, through our conversation tells me that I want to be blue team, I want to defend the network, and this is the area that you need to work with. Sometimes you have network engineers that you talk to or network admin. Sometimes this is also part of your criteria that your responsibility. So as an analyst, you need to be able to have an awareness of the tool that you can use and how you would take that information and interpret it and present it into a report, right, for a decision-making process. Any question? Okay, so we talked about PRTG, and it goes in depth, and I mentioned that WMI is a window management instrumentation. This is a way that we can interface and automate administrative tasks for Windows systems to monitor the activity on those systems. And then it gives you a little bit of description about the tools that we talked about, like SolarWinds. If you search, right, there are variations in the SolarWinds tool, and then Nagios and Cacti. Okay. Always want to go with the latest version. When you're pulling that from Git, especially your open source, and then making sure that you have the requirements on your system to be able to accommodate the application. So in the next section, which is page 4, it talks about beaconing. Our systems, a lot of the systems communicate by sending status to one another. Case example is your wireless router at home. It tells all your wireless devices that here I am alive, I am available, connect to me if you this is my ID, right? Your SSID, if you have the key. So if you enable that option for it to broadcast or beacon the information. So beaconing activity, this is considered sometimes called the heartbeat. This can also be used in a negative way, but let's talk about like how, right? Sometimes it would be used with encryption, or sometimes it can be difficult to identify. Sometimes it can be used to embed malware for remote activity, or integrate botnet control. So it goes both ways, right? So in the next question, it asks you explain why beaconing is needed in network analysis. We want to look at this information. What devices should be used to analyze beaconing? This is part of your network communication, and it is part of that particular device, like what I said about wireless router. Because in beaconing, it is a form of inquiring a status. Like, hey, are you there? Like, who's there, right? Like some systems, like some routers, it actually look at all the neighbors' routers. It's going to say who's nearby. It's kind of like you're standing in the street and you're trying to look for your neighbors, and so that way you can talk to them. And so some routers do that. But in beaconing, it sends request command, and it also provides its own status information, right? Like I am this ID, right? And who are you? Okay, so it's going to ask for information from the other system and also providing its own information. Now, in this process, sometimes that can also be an issue because it is a form to incorporate malware download, right? Because requests have response. And so if there's back and forth communication, it would be like, here I am, connect to me, right? Or let's communicate, and here's a file, okay? So that way we can communicate. Or we can use it for other activities, and from an attacker standpoint, they can manipulate your beaconing aspect or utilize it for their advantage, right? And the reason why we look at this is it's going to tell us a lot more about the indicator that's happening on our network. So it's an area that you need to check. So when you are detecting this behavior, right, you need to go back and look at your alarm system, which is your intrusion detection system, your intrusion prevention system. Why? Because if it goes undetected, that means that your rules are not effective, okay? Because we talked about how security appliance needs to be maintained. A lot of people think that, oh, if they buy a security solution, they buy a box and configure it and just run that box, it's generally okay. It's okay if there's no bypass, right? It's okay if there's no one that is taking over and modifying their logs and their system. So it's kind of like, how do you know if the attacker is undercover, if they mask their information, or if they're using activities like beaconing to be able to control the zombies that are on your network, their botnets, right? So the activity that you use that you're seeing in beaconing is going to help you determine whether botnet exists in that part of your infrastructure. And also if they're able to remotely control systems that are running inside your infrastructure. Okay. So that's important to think about. And it's really good to get this and put that on the report. And if you find nothing, that's a great thing, right? But it is an area that we would use to indicate that potentially we have a security issue. Or not potentially, we have a security issue if we see some behavior that's botnet based. So how do I know if something is remotely controlled? Protocols are going to be used to be able to remotely control systems. Like, like if I need to control the system where you're sitting at, I need to either directly communicate with it using some kind of protocol, or also I need to submit some command to, right? Like operating system command to be able to control your system. Kind of like if you are using a service where you can access someone's desktop, right? That has to be allowed, but in the back there has to be protocol and service. So we can see a lot of that based on and it has to go through the beaconing process. Any question? Okay. So that was 4. Let's take her down, or maybe take the other ones up. Okay, next we're gonna talk about what should be expected and what should be unexpected. So if you understand your network activity, if you benchmark and know that this is the normal activity for the heightened hours, maybe in the morning when everybody gets in, log into their systems and start doing work. And then, later on as we go, sometime there will be a light time. So when you benchmark these things, you are building a baseline to better understand what's happening on the network. Just like how you would know that, if I drive on the 91 freeway between, maybe 1 and 3 p.m., there might not be too much traffic. But if I hit the 91 freeway at 5 p.m., right, it will be like stop and go. Okay, so we have some expectation in our network traffic, but in the case that if someone is trying to probe or look for information about our network, like running Nmap, okay? And Nmap is a tool that we can use to look for ports, which are doors to our systems, right? Doors and windows. Nmap can also provide information like software and services, such as operating system that's used, right? Or the application that's installed, like web applications like Apache, NGINX, and so on, IIS. So if they're probing our systems, then that becomes irregular. It's not something that we have normally, right? So you would have unexpected traffic, and that would include your scans on your probe. Maybe it might be peer-to-peer connection, direct connection, or remote control type of connection. And that can change your traffic pattern. It's kind of like how there is everybody is driving on the freeway, and all of a sudden, right, you see a lot of police cars because they're escorting maybe someone, right? That becomes irregular. It's unexpected. It's different than what you see normally. So unexpected traffic, we would know that it would be outside of what we normally see in the trend of our network activity. Okay, so you have to know what is normal in your network to really see what's not normal in your network, which is the unexpected traffic. Like when they're probing it. So when you're running Nmap, it runs at least 1,000 scripts. Do you know that? So the more option that, depending on the option that you put, like, you know how I have to put Nmap space dash capital A for aggressive. So in the aggressive scan, you're going to run more script than if you're just looking for the operating system, right? Or you're looking for ports. So in that, it's going to continuously probing or inquiring about, the target. What does that target have? And it would run the script. So it would spike your traffic, and it would also directly target a certain set of system or a system on your network, right? Depending on the scope of the attack or the probe. Okay. So we want to really see the behavior, the heuristic behind this. And in network environment, protocol tells you a lot, right? Protocols, it relates to the port, the doors and windows to the system. It relates to the service that you use. So when you do protocol analysis, you would see what they're asking, what kind of probe they're using, okay? And you can block it. So in that case, when, to respond to it, going back to what we talked about last week, if you see the unexpected traffic, your response should be, we need to do something about it. If your security appliance system is not responding as it should, you would manually block it, block the IP, block the port, block the service, right? Okay, so coming back to the part where we talked about probe and scan, right? So how can you detect this? Usually probe is not a one shot, right? Even with ping, in Windows environment, when you ping, it's 4 packets for Windows systems, 4 requests and 4 response. In Linux system, and you can also create the amount of count, how many requests do you want, right? And Linux system, it continuously do that. So when they're running a scan or they're running a probe, and that's part of recon process, right? They have to know more about your system to attack your system. So you would see that the network scans would be sequentially testing or asking information about the doors and windows to your system, your ports. And it would also, they might inquire about addresses, your network block, like meaning your CIDR, your segment information, and it might do it in a range, right? Because they might not know specifically like how many servers you have. They might know like some IP information that you've used, and instead of targeting one specific, they don't know which one is the server. They're gonna do a range, right? And map, and a lot of the security tools allows you to do a range. Okay, so that's what you see with so what you would look at is you would look at the IP address information. You would look at the repeated request because it's gonna try to inquire until it gets some information. Any question? Now, if you see this, like I said, right, respond to it. A lot of the times, if you have effective rules with your security solutions, it would send off an alarm or it would block it. But if it doesn't, we would respond to it by, going back and modifying our rules to be able to be more effective. So that means that we go back to the security appliance, your intrusion prevention system, your IDS system, your firewall, right? Your SIEM system, and just to detect the scan. It's kind of like if someone wants to rob a place, they're going to check out the place, right? They're gonna see who goes, who comes, who goes, what it has. And probing and scanning is like that, right? Like which security guards, how many doors they have, blah blah blah, right? And what's inside. And so if we up the game in the appliance, we're just giving ourselves more time to be able to protect our resources, right? Like I said before, it's about buying time. Any question? Okay, so I'm gonna take 5 down to the next page. And some of you are still working on those. And 6. And then I'll talk about denial of service attacks. So I mentioned this before. If you have taken CIS-47B, we spent a week on denial of service attack, right? Denial of service attack is a form of attack to exhaust resources in a target system. It could be through some form of protocol. It would be to some form of service. So it would be asking the system to provide information or service until that system gets exhausted, right? So to stop it, we would look at the pattern of the traffic in the network. Network tells you everything. You guys saw that in the malware analysis. Credential information, right? The details about who's downloading, who's uploading, who's accessing what. So if they are targeting you, if you are getting, attack with enough service coming in from a source to a target, then if you have effective firewall or prevention, right, intrusion prevention system rules, it's going to block the traffic. That means that I will have many packets that are coming from that source to this particular target, my server, right? So anything above, let's say 5 packets, we want the alarm would start sounding off. Anything that is above 10 packets, we block, right? Because if you follow the conversation back and forth on the systems in Wireshark, you see that there are many packets that are being sent back and forth. So if you are false positive, a lot of the times we perform in a paranoia state, right? You might create issues, right? We slow down the communication in our system, but when you open it up too much, we become false negative. It it bypasses, right, a lot of the security issues. So we want to set up the rules in firewall. And how do I know, right, how many packets? Well, you can do a testing with it. You can also look at your network pattern, like what we've been talking about so far, to be able to derive that information. And it's varied from the service, the system, the enterprise, the business, the users, the number of systems, so on. So many components that goes into this. Okay. Any question? Now, your question to me should be also, how can I stop distributed denial of service attack? Distributed denial of service attack is harder, but still, you're gonna have one single target, right? Or it could be a group of servers internally. So they're gonna, you might see like 100 IP or 1,000 IP that's looking for requests from maybe 4 servers, 4 of your main servers or 1 of your main server to take it down, right? So with that, we set up the rules for it. If requests are being submitted from any unknown IP, inspect, right? Sound off the notification, let's look at it. And then anything that's above certain number of packets from unknown IP, block. And you see a lot of that happening with web application firewall in the data center for the web servers, the systems that are on the VNZ side of the house, even on the cloud environment. Okay, 8. What type of tools and methods are used to effectively detect distributed denial of service attack? We already talked about that already. Network performance monitoring rule tools, priority. That's your base, right? You cannot respond to any attack without looking at your network activity, for sure, right? So now and then you would dive into the rules that you set, how many anomalies did your system detect? How many anomalies did your prevention system block? Right? And then you analyze that as an analyst. So that could be an interview question, right? They might ask you, how would you go about detecting or stopping a denial of service attack, or how would you detect distributed denial of service attack? That's easy. I would start looking at my network performance using protocol analyzer, a capture, using some of the flow tools, right? We talked about that in the previous section, looking at the rules. You can also use command tools, command line based tool to look at your server traffic. Keep in mind that a lot of the servers, you cannot install additional tools to it because they might be limited to the resources that you're running. They're really functional based. That means that like some of your servers are managing cert, some of your servers, so you cannot add. So you're gonna use a systems that are connecting to it to monitor it. It's kind of like having a camera and looking at that house from an outside perspective instead of putting the camera on that particular house, right? So that would be helpful. But inside the server, every operating system has some kind of console or terminal or command line base. A lot of the appliance, we would start with that, right? Okay. That takes us to most of the information that you need for analyzing indicators, threat indicators on a network environment. Now we're going to hone in, right? So you start with the bigger scope, which is all your systems. Now we're going to dial into the host, which is the system, the server, the computer, right? The devices. It could be IoT. So how do you know if someone is connecting a rogue device on the network, like a wireless router, like Wi-Fi Pineapple, like, something that can circumvent the network? If you are MAC filtering, this is the key area. This is level 2, layer 2 of your OSI. When you set up MAC filter, your MAC filter list should contain the MAC addresses of the systems that you have on the network, right? The port that they use. And that's a correlation. So for someone to connect their own system into your network successfully, they have to spoof a MAC that is allowed on the network. They need to know what is allowed and what's not allowed, right, to be able to utilize the MAC that is allowed. Okay? So simple. If there's on a switch, if there's a port, I come by, I take a cable, I connect my systems to it. Will it work? If you MAC filter, it should not work because my system is mapping to, let's say, port 24 on that switch. But port 24 is disabled, so you turn that off. So there's no correlation with my MAC address for that port, so it doesn't work. So that means that you need to go and do an inventory of your MAC addresses, right? What systems, what MAC addresses you have in your network, validate them, okay? Now, if you find that there is a MAC address that is abnormal on your network because maybe your filter rules don't work accordingly, you should look. MAC address contain vendor information, the beginning bytes, right? It tells you Cisco, Dell, Intel, etc. So if you're not using that product, that should send a flag right away. You should know. Okay? Check the ports, because what I said, right? MAC to port. And that is going to help you understand where the system is in the network environment and which port it's using. Port tells you about service and physical connection and log. And then do a site survey. Actually walk through the areas that network are interconnected. Your systems are interconnected. It could be, a segment that where all your critical servers are connecting. So, or wireless areas, right? So site surveys is critical. So this really helped the blue team area, right? From the perspective that we look at the protection in a way that we need to know everything that is connected, all the system and how we would be able to respond to these potential threat. So now we're going to zoom in on the computer, the system itself, the server. If you have a single server, many servers, IoT devices, desktop, laptop, etc., right? How do you analyze those systems to be able to come up with like, oh, this system has issue, right? So we look at processor because if we're looking at malware activity, malware is it is a set of code that runs and it has typically they write it with functions or methods or routines to execute tasks, right? It might be like if you're looking at a keylogger, what does it do? It opens up the input signal, right? It listens for the input signal. Where's the input? Mouse, keyboard, right? Touch screen, etc. So with that, it needs to utilize two main elements in the hardware, CPU and RAM. Okay. Software utilize those two. When you write an application, it's the same thing. So malware, it's software, right? So you need to do CPU memory analysis. You need to look at memory leakage, okay? And then also storage capacity. Some malware, right, can be changing, like metamorphosis, right? They modify over time because it's based on the condition. So that means that it needs to take up resources like CPU and RAM, and a lot of the times it would need to be somewhere on the system using system files. And when we did malware analysis, you kind of see like how the Windows side, the DLL, like dynamic library that's being used for system resources and system activity and files. So that's what you see. So we look at storage capacity. Sometimes it will take up space or it might be embedded into something, right? File system change because malware capitalize on file system because file system is an area that the operating system use for resources. Any question? Okay, so let's take 9 and 10 down to the next part so I can cover the next few questions and bring these up. So, if you're looking at Windows operating system analysis, we can use a couple of tools. Performance Monitor been around for a long time. You're going to use that today for lab. And you can use it in the graphical user interface or the management console for Perfmon. Perfmon exists in your client system and your server system. In the prior versions of operating system, it only existed in various versions, like different editions. And then you have to install them if it doesn't, but now Perfmon is in all edition for Windows system. And then you can also use ResMon. So Performance Monitor allows you to really dive deep into like RAM components. So when you hit Control-Alt-Delete on your keyboard, right, you press the hotkeys and then you open up your task manager. Inside your task manager is already incorporated Performance Monitor. It tells you like the percentage of your CPU ID, your process ID. So if you're looking at malware is going to take the processes. So and in Windows, typically it runs as an executable, right? If it's packaged, so you would see all the processes and the sub-processes, and it would maximize, or it would capitalize on the resources that it has. So you're going to see a spike in system usage. Okay, so it will be heightened in the usage. Now, on the Linux side, we can mostly use commands. So on Monday, I spent a little bit more time explaining in the first part. So we only got to some part in Linux. We'll see how far we get. You might not be able to finish the second part, but I encourage you to use the lab as a practice tools, right? You can always go back and complete the exercises. So that way you can speak to the job that you're applying for. We give you the resources, right? You need to utilize it effectively so you can get the job that you need to get. So in Linux, you are going to use some of these tools. PS is going to give you processes, right? And then we're going to see top, df, and w commands. So there are many different type of commands that you can use to look at information relating your CPU and your RAM. Those two areas are really important for the host. Server, client, right? So now, if you're dealing with IoT, most IoT devices run embedded Linux. They don't necessarily have like Debian base, so some commands work across multiple versions of Linux, but not all commands. So it's always good to go back to the manufacturer and inquire about that. You might have to use a third-party tool to inspect like the resources, but if you're looking at like Android systems or Android-based systems, right, generally it's running Android. So you would be able to go through the system information to get more details. Any question? So 13 is kind of long. You don't have to put verbatim, right? You can summarize it. You can clip it from the notes. So now we're in the host area. And in the host area, the major threat is going to be your malware. Typically, you don't have specific attack aiming at people's system. When it's a single target like that, it's kind of rare. So if you might have like attack that's to the server, but typically for the user side, a user account, the profile has to be like, executive for something that a system that holds a lot of resources that they can potentially use across the network, right? Like admin systems and so on. But so we focus a little bit more on malware because it's more of a common threat across, right? So on 13, it says, how can malware and unauthorized software be detected? Well, you can use, in Windows environment, we can use Microsoft Endpoint Configuration Manager. Endpoint is really aimed for your endpoint systems, right? Like your desktop, your laptop, your, devices that you attach to the network. This allows you to manage what software can be installed on those computers, those systems. I used to be a sysadmin for some time for a private company. And we had implemented application server to control like the type of application you would push, whether it is through the network or web-based. And then centrally we use that to control like even down to like your browser that you use, right? The reason why is that there are specific services that would be used for the type of application that we ran. So you need to centralize that, right? Like have a system to be able to control what can be installed. You push an image for your user desktop and laptop so they are identical. There might be some exception in different level of positions that they would request other applications. Then that will be controlled through group membership for privilege and permissions. And then to be able to incorporate like specialized installation of software based on the request for those people. So in Microsoft environment, we would use that product. So that way, if let's say someone in finance department, if they want to install a game on their computer, right, to play during their break time, they cannot, right? So you want to also control access based on the accounts as well. So that means that user accounts should not be able to install anything. You need to have an elevated privilege in order to install, right? Like for service technician or, something like that. Now, if you're using anti-malware or antivirus or security tool, that is just a way to detect, right, malicious software, malicious application, so malware or files that can be used in a negative way to corrupt your system or to damage your system. That's what malware does, right? Depending on the type of malware, but ultimately it's aimed to corrupt your system files or, like encrypts everything, like ransomware, etc. But as you know, I mentioned that anti-malware is only effective to a certain percent. You cannot rely on it 100%. So we have to layer our security solution, right? You can also do live monitoring across your network with your anti-malware application. So you can have a server that is looking at all the other systems. I mentioned to you, right? Like I used to work in different areas of IT. And in one of the company I worked for, in order to attach to the wireless network, you have to have an anti-malware. You cannot. And it's a way that we control like what people bring in, especially if they're bringing their own systems and laptop and smartphones. So it does a health check on that. Even how you accept the license agreement, you just attach. But like the risk of attaching to the school network. We still have to prompt the user the agreement, but in that, right, like it would check for that type of application specifically. So it looks for the application file, and then it would be able to determine if that system can. So if you come in with no anti-malware on your smartphone, you cannot be connected because it just opens up a risk on that network. Okay. So you can also look at it that way. We can also create a list of what's allowed or not allowed in our systems and network, right? So you can create rules on your security appliances and say, if you see this application, right, don't let the user download any application outside of this list, right? Or if you see this application, notify the admin. So there's ways that we can look at how we would allow certain applications, and that would relate to files because software is used to generate data and access data. So all applications generate some form of file. Okay. So that's what you see. Questions? All right, like I said, you don't have to put verbatim, you can summarize it. My point in these exercises, you see it, you hear it, you learn it, right? You remember it. So I hope that these would give you the relevant information that you need to either get through the interview, do the job, right? Ultimately, I want to give you the concept so that way you apply and you'll be able to do it. So will you need to write what I put on the top? No, you can just write what you absorb, right? Or understand from that question and the concept. So how can you look at the operating system itself and say what's normal, what's not normal? Operating system is a software, right? Software utilize CPU and RAM. That means that we would need to inspect the system performance like what we talked about before. So when you use System Eternal's access check, these tools look at the performance itself, what files are being used by the operating system. So if you need to explain operating system to an 8-year-old, right? Like what is an operating system? It is a software for us to interface with the computer to manage the resources within it. Basically that, right? That means that you can keep photos, images, video, files in it and access it. We can interface it to configure it, to access files, to use the application within it. That's considered resources. So we need to really look at the behavior of what this operating system really does, right? Typically, an operating system would have two level, and I touched on this on the Monday lab. The reason why is you're going to see these components. There's the user layer and there's the system layer. Your operating system uses the system layer to be able to access different areas of the kernel to give you the resources. So when you download, you run application, it is using the system layer to run, to give you all the things to have the task executed with your processor to queue, processes to be able to pull files and so on. And the attacker, they know that at the system level, at the OS level, if they do OS command, OS control, that means that they can run it at the system level. Typically, system layer is protected when they create the operating system. What you see from the user layer, even if you are as an admin, you cannot access some areas that the system has, right? So you see some advanced level malware that capitalize on the resources like this. So you need to really determine what is normal in an operating system. Like if we're running Linux and Windows, right? Look at the version and create a baseline. What is the normal activity for my OS? And what is abnormal? So you need to go back and look at the permissions. Why? Because files related to permission, what the system access, what the user access, right? And then the privilege, because the system account, if you're looking at Windows environment, if you right click, go to properties and look at the security tab, system account has full access, right? Same thing with the admin, but system account has lower level access, okay? So the privilege in that is also important. And this is a big area for IT audit, right? So speaking to this, outside beyond the analyst is the IT auditor. So if you function as an analyst, your next level is to move into IT audit or security audit. Typically, that means that you come back and you see if these things are there, your checklist, right? External auditor, internal auditor, etc. And those are the people who comes in and making sure that things are in place. Okay, so when you make changes on your operating system or your hardware, like for example, I buy a wireless USB adapter and I plug it into my computer, right? I want to be able to use the wireless adapter to access my wireless network. It creates a change in your registry. So registry is a database that your system has to have information about what hardware and what software exists. So when you install a software, it generates a value change in the key, your H key. When you install a hardware, like let's say I add a new solid state drive, I added a new adapter, I installed new components, hardware components to my system, it adds values to the change. You learn this in A+ CIS-45. You should. And in forensic, that's really important. In security, that's important for us. Why? Not just to respond, but registry tells us historically and current what your system has, right? So if you're dealing with malware, registry has it. If you're dealing with memory leakage, registry contains some information. There's changes to it, right? So that means that if we want to control what's being modified, we really need to take a look at what software is allowed, right? Because if you let people install software, it changes the registry. So don't let people change the software, okay? You need to make sure that your operating system is up to date to fix some problem, because OS is the software and OS it works directly with registry to pull the application that you need. How can you click the Chrome browser and it opens? Well, your operating system, right, finds the information in the registry key value and say, oh, that's the application. That's how I'm going to open it and give you the resource, right? And then agents tool to really look at false positive detection. Is false positive good or bad? I mean, both ways. It's no good and it's not bad. It's just we're gonna operate. There's nothing perfect, right? So if you don't know this, most of you know how to do reg edit, right? So people should not be able to change this as a user. I can view it as a user account. Reg edit is the editor to your registry. You can see everything, like all the things. You see there's Mozilla. Why? Because Mozilla Firefox is installed, right? So it has all the components that relate to software under software. It's pretty self-explanatory. There's your local machines, H key. There's your current user. There's classes for root. And as you go through, when you're looking at, see how I don't have privilege for that? But, even down to your token for that system. So this is a perfect area for Windows forensic. I have a former colleague or a friend that works with SANS, and he specialized in Windows forensic. He's an expert in it, right? So they really emphasize this. It is an area that we can see everything that had happened to the system, and that's on the system for sure. Okay. Any question? So don't let people change your registry information, and you can use it to detect, right, changes. And then in Linux, how can you view your status or your system service? You guys know how to do it in Windows? Most of you know. If you don't know, you need to know, right? Service is critical in security. Why? Because service, like I said, ties all application has some form of service. Your Chrome browser has a service, right? My Microsoft Office 365 has services because it's web connected. A lot of things have services. So in Linux, we use service base / status all gives us all the service you need. In Windows system, go to service console. Just type in services in your search bar, and as a user, I can see the services. So your services console gives you the details about the services that you're running that is relevant to applications, software, things that you use, right? In your system, things that are currently running, because maybe I'm running application, maybe I'm using the resources. Some are disabled, some are automatic, some are manual, and Linux and systems, all operating systems have this. Okay. Why do we care to check this? Well, potentially if you have someone remotely connecting to your system, like what we talked about in the earlier example, yeah, that service is going to be running, right? And then they can also automate the process, right? By scheduling that service. You see this with a lot of malware. You ever hear people say, I turn on my computer, it keeps trying to connect to the internet, and I can't do anything on my computer. Why? Because it capitalized on all the resources to run that service continuously. So the user has no space, no resources left to run anything else, right? So it just maxed out. And when you look at the performance level for that, the processes is spiked at once at the beginning, right? So now we know. I think if you took my CS-27, you've seen that before, but I'm sure you've seen it through some lab or tutorials or. Okay, let's take 16 down. And we're 17. So I'm trying to get through because the lab is kind of long today to give you some time, right? Like I said, if you don't completely finish the second part, I totally understand. Try to finish it. Because when you get to that copy and paste command, but I don't want you to just copy and paste command and screenshot for me, okay? I'm going to reiterate this. A lot of students, they were like, oh, I don't know what that is, but here's a screenshot, right? I see that when they note that in the lab. But it's this is not for you. I write these assignments in lab for you. This is not for me. But let me correct that. It's not for me, it's for you. So when you go back and you look at the screenshot, you're like, oh, I ran this and this is what it should look like. This is the output. This is the outcome for it. And this is what it needs, right? So pay attention to what you're seeing. Take a moment and then absorb what you're doing because, these things are not like rote memory. It's not like something that you routine that you have to remember. It's about something that you understand. And this is, if you need to do it, you know how to do it. That's important. Okay. So I want to emphasize that because I see a lot of lab coming in like, oh, this is an error. I don't know why it's an error, but I want to show you that it's an error, right? Like call me over, look, search, research, ask AI about the error. Like, why am I getting that error? Like maybe I typed in something wrong. Maybe the service is not running, right? Learn a little bit more about the error. Okay. What type of analysis should be performed to detect application attacks? So when you're dealing with application, likely the majority of the companies are going to run web application. You know this, right? Everybody has an app. Everybody use mobile devices. So you're going to look at the services of the application. Like I said, every application has some form of service, whether it's connection, whether it turns on the signal, encryption, right? So some form of service for the application to generate and data and access data. Okay. And then looking at the errors that the application logs gives you, okay? Because we learn about fuzzing, right? Fuzzing is a way that we break things to see what's wrong, particularly application. You can fuzz the application until it gives you some kind of error, and the error tells us about that application because the attacker might not know about the construction of the application, the component, the element of the application or its feature. So they're going to run the error. They're going to run fuzz and it's going to get the error. Okay. Then the behaviors. So a lot of it comes back to your logs and your monitoring system. It's going to tell you a lot more about the story behind your application. If you have malware infections, right? Malware, depending on the type of malware, but it will target whether it's file viruses. So it would attach to components of your application, the data, right? Or the services, the resources of the application, depending on the code of the malware. So if there's information about malware infection for that particular application, but the vulnerability in the applications, it's always gonna be there, right? Until they close it, they fix the code. So if you know about CVE for your software, that's important. But I really feel like a lot of things come back to access management, how you control resources, right? Like who access configuration for the application, who can access the components of the application, like modifying an update, who can access the data of the application. So account access and access management is critical in many areas. And then application use processor and memory usage. So you have to keep a close eye on that for sure. And I emphasize this across CIS classes. You write application to use memory to store data temporary. We don't put data permanent here, right? We send the data to the database. So you typically see cache or memory type of allocation for temporary data storage. And then that gets put into a permanent location. If you have a lot of data that needs to be constructed into the database, so when you learn programming, a lot of times you're like, oh, this variable holds this and this container like array holds this group of data. But we don't always keep it there, right? If you compile an application, it flushes that all the variable information and all of that after the application is ran. So you have to rerun it to maintain the data. So we want to take the data and put it into a safe place and protect it. Any question? So we have like a few more lectures and lab. So, and then you will have your practice exam. Until we get to that time, we're gonna still require attendance and assignments, I will give you some time to work on your practice certification exam, and I will release that. And then the end, you're gonna have a final multiple choice, final exam. That's a different test than the practice exam. So we're gonna allocate time for that, for those two. Okay. But we do have a few more things to address before the end of course. Any question? Let me stop share real quick.